Here we can see the bubbling bed boiler. It has inbed evaporator tubes and superheater tubes in the convective shaft. So in here we can see the superheater in right side. The combustion air is in the left column bottom. Bed drain is also available. The flue gases going through the economizer. Coal and limestone are input of the boiler in the left column. The air goes to the right side column, and solids are again recirculating to the bed by particulate recycled pipe or duct. In here the next diagram we can see the circulating bed fluidized bed modular design for cost effective field installation and advanced emission control is possible. In here we can see in the left column the bed drain is available. Air inlet is given to the bed at the left side of the column, and fuel servant is giving us input in the left column of the boiler. Fluidized bed combustor is available in the left side of left column of the boiler. Hot recycle cyclone is available. Fines return is available. So the flue gas is going through the combustor and hot recycle cyclones. After the hot recycle cyclones, the fine returns. The flue gas is going to the right side of the column, which provides the superheater and first stage superheater and second stage superheater, then economizer, then it is going to the air preheater, and the ash is collecting through the right side of the column. The next diagram shows fluidized velocity of air. The graph, it is velocity and increasing expansion. Fluidizing velocity of air is the fundamental distinguishing feature of fluidized bed combustion units. Bubbling beds have low air velocity while the CFBCs have higher. In here we can see the graph. That sloping graph is showing mean solid velocity, and the mean air velocity is straight line. Fixed bed having 0.3 to 1.2 meter per second, and bubbling bed having velocity 1.2 to 3.6 meter per second. Circulating bed having velocity of 3.6 to 9 meter per second. Transport reactor have 9 meter per second velocity. This is graph velocity to increasing expansion. So we can see the next question. What is the layout of evaporator tubes in AFB units? The evaporator tubes serve as a suitable heat sink in the combustion area to control temperature. They are laid out in the traditional pattern of water wall enclosures. There may be different designs, as for instance, where the boiler tubes are located within the bed itself. Next question. Does this mean that only the water tube design is possible? Answer is no. Both water tube and fire tube designs are possible. Fire tube boilers are more popular for larger sizes. Next question. How is steaming rate controlled in AFB units? Answer. This is affected by manipulating the primary bed parameters, means bed height, bed temperature, inventory, plus controlling the superficial gas velocity. Indeed, the manipulation of gas velocity accomplishes most of the control. Next question. Why the bubbling fluidized bed boilers so called? Answer. The combustor of such boilers are provided with a grid upon which is supported a dense bed of fuel and limestone. The bed is maintained in a fluid-like state by air blown up through the grid and the bed from the bottom of grid holes. As the air flows upwards, it mixes the limestone and fuel and at the same time keeps the bed in suspension. The action of air creates extreme turbulence in the bed material and produces the effect of a bubbling fluid. The next question. Cannot bubbling fluidized bed boilers be made amenable to limited load fluctuations? Answer is yes, limited load fluctuation can be made possible. Next question. How can bubbling fluidized bed boilers be made amenable to limited load fluctuation? Answer by lessening the amount of air passing through the bed. Why? This is lowers the bed depth and retards combustion. Next question. What is bed slumping? Answer. Reducing bed depth is sometimes called bed slumping. Next question. Why must the velocity of air through the bed be kept always above the minimum fluidization velocity? Minimum fluidizing velocity. Why must the velocity of air through the bed be kept always above the minimum fluidizing velocity? Answer. To avoid incomplete combustion which result in smoking. If the velocity of air through the bed is below the minimum fluidizing velocity, it will affect the removal of sulfur dioxide. Next question. How many types of bubbling bed boilers are there? There are two. Single stage bubbling bed units, two stage bubbling bed units. Question. What is the concept behind two stage bubbling bed units? Answer. The basis idea is to separate the combustion process from absorption process so that each can be optimized without the design compromises inherent in the single bed unit. For instance, a higher combustion temperature can be attained in a lower bed since absorption is no longer limited factor. Next question. What is the world's largest bubbling bed boiler? Answer. It is the 160 megawatt bubbling bed boiler of Tennessee Valley Authority. Till date 1989, it is the largest AFB bubbling bed unit. Question. What are the important factors of the largest bubbling bed unit? Answer. It supports a single leveled bed divided into 12 compartments. It has under bed feed system. Its primary superheater and evaporator are fitted in the bed. Its finishing superheater and reheater are fitted in split convection pass. Main steam temperature controlled by spray water. Reheat steam temperature controlled by gas flow temperature dampers. Next question. What is the world's largest circulating fluidized bed unit? Answer. It is 150 megawatt unit of the Texas New Mexico Power Company. This is the world's largest circulating fluidized bed unit. The next question. What is the fuel of the largest circulating fluidized bed unit? Texas lignite. Next question. What are the important features of this largest circulating fluidized bed unit? Answer. Dense phase injection in the combustor. Single combustor system fitted with water cooled valves, grate and plenum. 4 refractory lines lined cyclones for recirculation of unburnt fuel. 2 member of external fluidized bed heat exchangers FBHE each with water cooled valves. 1 FABHE external fluidized bed heat exchangers sports a superheater and evaporator while the other has one reheater and superheater. Next question. What are the advantages of CFB units over bubbling bed systems? Answer. Larger residence time of fuel that enhance combustion efficiency, greater amount of absorption of SO2 and other acid gases because of longer residence time. Use can be made of less prepared fuel and solvent, free from many problems associated with underbed and overbed feeding of the fuel as encountered in bubbling bed combustion system. The next question, what is common disadvantages of CFB units? Higher electricity bill because of greater fan power required to maintain the higher velocity through the bed. What is PFBC? It means pressurized fluidized bed combustion. Next question, what are the two key features that distinguish PFBC units from AFBC units? Combustion takes place at a pressure higher than the atmosphere. It couples two cycle convectional steam boiler steam turbine cycle with the gas turbine cycle. So next question, how does PFBC boiler work? Fluidized bed combustion takes place at elevated pressures. It incorporates a gas turbine that drives an air compressor which supplies combustion air at high pressure to the fluidized bed combustor. The resulting flue gas, also at high pressure, is cleaned off suspended solids and directed to drive the gas turbine. Evaporator tubes laid out in the fluidized bed combustion abstract the heat generated, producing steam which drives its steam turbine to produce 80% of the unit power. Thank you.